It is now my pleasure to introduce to you today's presenter, Fred Romig. Take it away.
Thank you, sir, and welcome everybody to this good presentation that's forthcoming. So here's what we're going to talk about today. We're going to talk about how to keep our environment, employees, and facilities safe regarding hazardous chemicals. To talk about all types of facilities that exist above or below ground in industrial, institutional, or commercial settings is too big of a task for this presentation. So we're going to whittle this thing down. We're going to focus on a single, unique structure that, for the most part, has more stringent code requirements. We're going to discuss why a hazmat chemical building, regardless of its contents or use, is probably the safest building on any industrial site. This is because it's constructed to meet or exceed tougher specific codes. What is a hazardous chemical building? A chemical building is designed to protect property and employees from fire and explosions while storing, mixing, dispensing, testing, and handling hazard materials, especially flammable and combustible liquid chemicals. Chemical-related accidents do happen on industrial sites. Many, as you know, the Occupational Safety and Health Administration, that's OSHA, O-S-H-A, was created to protect workers from such accidents. The Environmental Protection Agency, that's the EPA, was established to protect our environment. Prior, more than 100 years of codes were pulled together by thousands of highly educated, trained, and experienced committee experts from the equipment, manufacturing, enforcement, insurance, safety, research, and other related fields. Why? Why? Because millions of dollars went up in smoke as property were damaged or destroyed, and lives were lost, and workers, many, disabled. All because there were not enough standards, or if there were, they were ignored or were not strong enough or nor enforced. This is a serious business. Now, prior to OSHA and the EPA's foundation, the National Fire Protection Association, that's NFPA, and the National Building Codes Association, that's BOCA, B-O-C-A, was established earlier around the turn of the 19th century. These organizations have instituted codes that define requirements for chemical building construction that meet minimum strength, fire, and explosion standards. NFPA and BOCA were founded and have been the foundation for the international codes that have come much more recently. These codes have limited the total footprint of a chemical building not to exceed 1,500 square feet. Yet, the largest one ever built was 3,182 square feet per floor, shipped in 24 modules for the General Motors powertrain division. This was due to the relationship the user had with the local authorities and are self-insured. This was utilized for testing large truck engines and their transmissions. Now imagine the amount of codes that had to be considered in getting this building approved. These codes were established from trial and error experiences and results from all types of disasters and scientific testing over 100 years. Here's an example, as you see, of one building moving slowly, making a very tight turn onto a bridge in a small rural town with an escort car out in front. The turn was complicated because the building was 72 foot long and 12 foot wide. They had to remove posted signs even to get over the curbs. As for extreme dimensions, a building's height has caused the most trouble. For example, I know of an incident when an escort car with its steel height testing pole moved into the left lane of a dual highway while going under a bridge. But the tractor trailer, with its tall hazmat building, could not find a way through the traffic to follow the escort over into the next lane. The driver felt a bump and just kept going. A police car saw the sparks fly as the building's roof hit the bridge, and then on down the road where the free tie-down chains clattered on the highway. The officer chased down the tractor-trailer to inform the driver of what had taken place. The clearance under the bridge on the right next to the berm was inches lower than the clearance in the left lane next to the medium strip. So the car was able to get under the bridge, but not the truck. Some observers and the officers, they all get a good laugh recalling this story, especially the officer, because he was chasing that car and trying to avoid at the same time running over the chains for fearing what it might do to his vehicle. The shipping company paid more to repair the bridge than was the damage to the hazmat building because of how strongly they're built. This second photo of the long building shows a couple of cranes at the back of the client's main facility. These cranes are lifting the same hazmat building off the trailer, and it is about to place down on a concrete pad, pre-poured by the client. Now this next picture is a night shot of the front of the building. It may have been the first and could still be the longest single hazmat building ever built. And again, at 72 foot long, it has 5 separate rooms, 2 of which were flammable and combustible liquids, and the rest were for non-combustible storage. The design of a hazmat building must meet or exceed local, national, and international minimum and maximum thresholds. These include dimensions, strengths, roof snow accumulation loads, wall wind loads, storage capacities, fire and explosion resistant construction, alarm systems, and more. The building in this photo was called a tank farm. Here you are looking into the open top of the 2 lower modules already installed on the client's concrete pad. Using a crane, the client has placed 2 of their mixing tanks into the floor of the hazmat building. In the next picture, now the second of 2 upper modules is being placed in its proper location to complete the tank farm. To cap off these buildings' unusual dimensions, here is the tallest known chemical storage building utilizing 3 modules stacked on top of each other to make it 3 stories high. The 8-foot high lower level was for storage, and the upper 17-foot high level was for experimental testing.